Yes, yes.
Yeah.
Yeah. Do you have any doubt in simple linear regression? Anyone? Today's session will not be so long. So whatever we have discussed in the simple linear regression, that will be some multiple linear regression will be some extension of that. So if you have any doubt, we can also clarify that in simple linear regression.
I have the doubt in that table, intercept GRE score one.
Which one?
There was a
Okay,
table.
okay, okay. Yeah, yeah, yeah. Um, yeah, this one.
Yeah. So how this table is formed? Like, what is the basic concept behind it?
You are there in the last session?
No, but I saw the video recording, like the YouTube video.
Okay. Yeah, yeah. So this is the output actually. I had one data set. The data was all about, if you see the dependent variable was, I guess, the chances of admission, and the independent variable was GRE score. Means there are two variables in the data set. One was GRE score and one was chances of admission. So I had taken chances of admission as my dependent variable and GRE score as my independent variable. Why? Now we can say now GRE score is high means if my score is high, then my chances of admission on a particular university will be high. Correct?
Yes, yes. Like
Uh,
if you want to make the same data for a previous sum, like what we were doing, so
yeah.
how we make that? What will be the standard error basically? The SB part.
For what?
The coefficient, I got the coefficient. Coefficient for intercept is beta and for GRE score is beta 1. How we'll get the standard error part? SB.
Uh, Standard edition. No?
Yeah, yeah, this one.
This is calculated by using the software only that has calculated this one.
In exam, we'll be able, like we'll have to calculate it manually, right?
Yeah, you have to.
So can you just tell me how to get this if we'll see the previous sum we have done?
If you know this one, the coefficient and the t statistics.
Yeah, then so we can divide. But if
Yeah,
we don't know the t statistic, if we have to find everything from scratch, like the standard error, then is there any formula for this standard
there
error?
is one formula. I forgot the formula. I have to think. Mm, Let me check if I have the formula. There is one formula, but they will not ask you to calculate it. It's not there in the PPT. Is it not there in the PPT?
I have not checked that.
Okay, let me check once. Standard error. Yeah, got this. So it is SSE divided by one second. It is not relevant. No, no, they will not ask you to calculate this one. They will ask you to calculate this standard error. Can you see my screen?
Yes, yes. Then how to calculate that? If
This one formula is summation of SSE, summation of SSE divided by n minus k minus 1. So let me check on summation of SSE. Yeah. So this formula is SSE, this one, SSE divided by n minus k minus 1 whole under root.
Whole under root, like SSC will also be there, right?
Yeah, yeah. First you have to
Okay.
do SSE divided by n minus k minus 1. So 2.88 is my SSE, na? 2.887 divided by 398 in the answer, under root answer in your calculator.
Yes, yes, got it.
Yeah.
Thank you.
They will ask you to calculate this one. This one will be done through the software only. If I got the formula, I'll tell you. Okay. But this one they might ask you to calculate the standard error, right?
Yeah, okay, okay. Thank you.
Anyone, any doubt?
Hmm.
Bata do. Anyone?
Significance here is zero, so that also counts, right? Usually it
Yeah,
is like it should be less than the confidence, uh, the
here
key
the
value,
model is
whatever we get.
significant.
Okay,
Here, whatever we have taken the model, like I have taken GRD score as a dependent, as independent variable, and my test statistics as, the chances of admission as my dependent variable. So whatever I have taken, the model is significant here, as
okay,
the if a value is less than 0.05, whatever it is, 0.05 or 0.01.
okay.
Generally, we take 95% confidence interval, so alpha value
Yeah.
will be 0.05.
Okay.
In this particular type of problem, you will be getting this kind of scenarios. Like they'll be giving the entire output, and there will be here and there some missing value will be there. So you have to find using the formula, whatever you know. In our time, in the last session also, I told that in our time there was one question. There were 5 or 6 missing value, and the question was about 10 marks question in the semester paper. And this one I was talking about in the last session. So they will give you one small data set like 10 or 15. Uh, X and Y will be given to you, means dependent variable and independent variable. So this will be for simple linear regression. So one independent variable will be given to you, and you have to calculate, you have to find the regression equation, uh, and you have to do all the calculation manually. So this is the first step. You have to find the regression equation. So for that, you have to find all those things manually. And in the second step, you have to find all those like ANOVA table, the calculation part of ANOVA table. So this is what we have to do in the second step. Another table you have to form to find all those in like ANOVA table you have to find. Next, if we want to find what was like the regression statistics, like the multiple R square, adjusted R square, standard error also. I forgot to talk about this one. So today I set the formula. Okay. So this is how we calculate R square, adjusted R square, right? So today, last class we didn't talk about the significance of this. What is the interpretation of these values, these particular values, and these particular values? Today we'll be talking about this. Okay. We all know till this point, like a value is zero point 0 or less than alpha means the model is significant. Whatever the model we have taken, the model is significant. That interpretation we know, and we know how to interpret the regression equation. Do you know that how to interpret a regression equation? Anyone? How to interpret the regression equation? Can anyone interpret this equation? This one. Can anyone interpret? My dependent variable here is chances of admission. Can anyone interpret this?
So minus 2.436 will be for everyone, it will be common, and then the GRE score, and then the chances of admission will depend majorly on the GRE score.
Yeah, that is fine. That is what you have to uh, know before you start the regression process. I'm talking about after you finding the regression equation, what will be the interpretation of this equation? So dependent variable here is chances of admission. So y cap is equal to chances of admission is equal to minus 2.436 plus 0.099 into GRE score. That is what the regression equation is, right? So what will be the interpretation of that? How do you interpret that?
So you are asking what will be the dependent and independent variable.
नहीं, dependent independent variable you have to know before you start the regression process.
Hmm.
Then only you can start the regression. Okay, I'm talking about the interpretation of this part. What is the meaning of this regression equation? That is what simple task. Okay, let me talk.
Is
Talk
it
about
that
that.
that there is a the weightage of GRE score will be 0.0099
No, no,
in the
no,
whole? Okay.
no. If you want to write, you can write. You might, and they might ask this type of question also in MCQ paper. Also, they can give one simple equation, and they might ask to interpret the this regression equation. So if you want to write, you write first write this equation, then you can write the interpretation. So first we will be interpreting as it is a simple linear regression. We will be every time we will be interpreting with respect to the independent variable. If it's multiple linear regression and there is two independent variable, GRE score and suppose what else we can take, chances of admission depend on GRE score and the suppose uh, grade of the university. Okay, two independent variable is there, GRE score and the grade of the university, or the NIRF ranking, I can say NIRF ranking, right? So every time we'll be going through one independent variable. First we'll take one independent variable, then second independent variable. So there will be two interpretation. If there is two independent variable, there will be two interpretation. So as it is simple linear regression. So one independent variable is there. We'll be interpreting only with respect to GRE score. Okay. So the interpretation will be like this. With the change of 1 unit of GRE score, there will be increase of 0.099 on the chances of admission. You can modify the English sentence, but the motive should be same.
Can you repeat slowly once again?
Yeah. So 1 unit change of GRE score, 1 unit change of GRE score will impact on or will increase point 0099 this one, this particular value, point 0099 will increase point 0099 chances of admission. Is it clear, everyone? Clear, everyone?
Yeah, sure.
Yeah.
Yeah. This is what how you have to interpret the regression equation. And any other doubt? If you have watched the video or if you have go through the Excel sheet, this Excel sheet I've already said. Any doubt, everyone? One second, I'll be setting the PPT. Screen. Yeah. So can we start with multiple linear regression? I hope it's clear to everyone, like simple linear regression. right?
Yes.
Yeah. So in multiple linear regression, we all know that there will be more than one independent variable. Okay. So this is the simple logic of multiple linear regression. There will be one dependent variable, but more than one independent variable. Can anyone give one example of multiple linear regression? What can be one example? Anyone?
Can we like take due to change in price, the demand and supply get affected?
Change in price, demand and supply.
Yeah,
Okay. So which one is your dependent and which one is your independent?
I
I'm
think
talking about multiple linear regression, not simple. There will be more than one independent variable. If we talk about sales, the best example always for regression to easily understand, we always use sales data.
We can take
So
the example of a blood pressure also.
blood pressure for what?
For the independent variable like the height, weight, age, and hours of exercise per week,
Okay,
we
that
can
will
take it as
blood
the
pressure will be
variables.
dependent variable.
Sorry?
Blood pressure will be what type of variable?
Yeah, blood pressure will be the dependent variable. But the
Okay,
independent variables will be like the height, weight, age, and hours of exercise we are doing per week and everything.
yeah, yeah, perfect example. Another example which I used to use is sales data. Sales is dependent on price. If it is only dependent on price, that is simple linear regression, you can say. If it is dependent on price as well as the quality of product as well as the number of retail store available on a particular city, so there will be more than one variable, right? Sales is a dependent variable. It is dependent on price, the quality of product, and the number of retail store on a particular city. So how many independent variables are there? I have three independent variables here. So I can easily, if I have the data, I can easily run a multiple linear regression model. Okay. So this is how we represent the multiple linear regression model. Y is equal to beta naught plus beta 1 x1, beta 2 x2, and like that will go on continue till beta n of n or beta p xp, whatever, however you can represent it. How many numbers of variable you have, it will go on continue till that point. And the last term, that is epsilon, this is the error term. Okay. So there will be always one error if we interpret something from a regression means what? We have the past data and we are interpreting something, right? Regression is one type of prediction or forecasting method, right? So if you forecast or predict, there will always be some error, right? Chances of error will be there. So this is what how this is the epsilon term is representation of error. So beta 1, beta 2, all this beta term is the parameter and epsilon is the random variable called error term. Okay. And this is what the regression equation is. That was the model. If we use instead of B we use beta, that is regression model. Okay, got it everyone? Beta is a parameter and B is the representation of statistics, sample statistics. We are taking a particular sample here and we are running the regression. That is we have taken small b, not beta. Equation will be same, b naught plus b1 x1 b2 x2, like that it will go on continue till bn xn, right? And yeah, this is what one example of multiple linear regression model or data set. So here the data talks about experience in year, the test score, and the salary. So which one will be here the dependent variable and which two will be your independent variable? Can anyone try?
Salary will be dependent and experience and test score will be independent.
Yeah, perfect. So experience is high means generally what we say experience More experience means that person will
Higher
earn more
salary.
salary. Test score is high means you will earn more salary. Okay. Salary is dependent on both the both test score and as well as the experience. So I can say salary is my dependent variable and test score and experience is my independent variable. So this is what my regression model is, and now what I will do. This is what the output is. And remember one thing: in exam, you don't have to run the multiple linear regression process, or you don't have to calculate manually the multiple linear regression. You only have to calculate simple linear regression that we discussed in the last session to the Excel sheet. Okay. So for multiple linear regression, you'll be getting some problems to either you have to interpret something, the output value will be given to you, you have to interpret something, or you have to find some missing value from that particular output table. Got it? This is what type of question you can expect in semester paper. Okay, so this is the coefficient table, we can say, right? Coefficient table. The coefficient value is given, the coefficient error is given, and the t statistics is given, and the probability value is also given. So they have used some softwares to run this, probably Excel or SPSS. Okay, so using this coefficient table, I can write the regression equation, correct? Can anyone tell me what will be the regression equation? I'll show you again the dependent and the independent variable. The salary is the dependent variable, test score and experience is the independent variable. Now tell me how will you write the regression
So
equation?
y cap equals to 3.17394 plus 1.4039 into x1. The x1 is experience,
Mhm.
and plus 0.25089 into test score
Yeah,
x2.
right, right. So instead of y cap, I can write what was my dependent variable? Salary.
Salary.
Yeah, salary equal to 3.17 plus 1.4 into experience plus 0.25 into test score. This is what the regression equation. Now next step is that in the question, if they give you this table and they might ask you to write the regression equation, you can easily write that. Next step is you have to interpret that. Okay. So as you can see here, two independent variables, so you have to interpret two times with respect to experience once and with respect to test score once. Correct. So what will be my interpretation? In the first step, I am taking experience as my reference point. So how I'll write, if you want to write, you can write. Do you want to write? So that I'll take slowly then.
Yes.
Yeah, so before you write this equation. That will help you to understand. Write the equation first, then I'll tell. Salary is equal to 3.174 plus 1.404 into experience plus 0.251 into score. Done?
Yes.
Yeah. So
Yeah.
first, keep the heading like experience. Experience then underline in the next line. Experience then underline means with respect to experience, I am interpreting the equation now. Okay. So it will start like this. When test score is fixed or constant, when test score is constant, then 1 unit change of experience, then 1 unit change of experience will increase the will help in increase the salary by 1.404. If you want to modify the sentence,
Can you repeat it once?
when test score is constant, when test score is constant, then 1 unit change of experience, then 1 unit change of experience will increase the salary by 1.404. Does it make
Will
sense?
it will increase the salary by?
1.404, the this value only, no?
Okay.
1.40.
Yeah, yeah.
Is it making some sense? Are you getting why I'm writing this? Leave this part. Sorry. This part is constant now. Okay. So
Yeah, yeah.
forget about this one. 1 unit change in experience means the salary will increase by 1.404. Correct?
Yeah.
Every time if you increase 2, then it will increase again 1.404. If you increase 3, if I make it 3, then again it will increase by 1.404. So every unit change in experience, the salary will increase by 1.404. Got it, Ashna?
Yeah, yeah, got it.
Yes.
Yeah. Next put the heading or the write score and then underline. So now we'll be interpreting with respect to score. Can you all do this? Do that.
So we'll write one
You are
unit.
right. When experience is constant, then 1 unit
Yeah.
change in
Yeah.
the
That you have
score
to
will
show.
help in increase in the salary by
Increase in
0.2.
the. Yeah. Okay. Let me repeat. So for score, with respect to score, and I want to interpret it. So I will keep my experience as constant. So when experience is constant, 1 unit change of score or test score, whatever you have written, 1 unit change of score will increase the salary by 0.251. How many interpretation can be possible here? Done, everyone?
Maybe one with respect to both the variables, as in one with
No, no,
experience
no.
and
Both the variables we won't interpret. There is no meaning of that. We can interpret one more thing, right? With respect to this constant value.
oh yes, if we keep the other two constant as well.
Yeah. So write the heading now as constant. Constant value we can write. For constant value, this one. This one is constant, right? This says constant. So for constant, it will be like when experience and score both are constant or both are fixed, you can write constant or fixed. When experience and score both are constant, then the salary will have a constant value of 3.174. Got it, everyone?
Can you repeat it
Yeah.
again?
When experience and score both are fixed or constant, when experience and score both are fixed, then the then salary will have a constant value of 3.174. Correct. Now I guess you can interpret the regression equation irrespective of how many variables are there, right?
Yeah.
Okay. So these are all we had discussed in the last session. There is not much difference in the output. Only thing is that there will be in the ANOVA table there will be no changes. Okay. The only thing is that you will have the changes in your let me finish that. We already discussed this, right? How to calculate SSR, SSC, SST. If you have attended, or if you can go through the Excel sheet, you can find that. So I'll not be going to explain all those things again. So let me come to the data set directly. Let me check the directory. Okay, we'll be doing that. Okay, fine. Any doubt till now, anyone? Any doubt till now, anyone?
No.
No.
So what you can see the difference in the output table. You don't need to calculate regression manually, multiple regression manually. So focus on the output table. There is not much difference, right? In simple linear regression and the multiple linear regression. Only one extra a variable is added here in the coefficient table. There is one dependent variable and two independent variables, so one extra variable is added here. That is what the difference you can see in the regression output table. Otherwise, the table looks similar. Correct? Right now, what? Clear to everyone?
Yes, yes.
Yes.
So I have one data set like student, test score, IQ, and study hour. So according to you, which one will be the dependent variable? Which two will be your independent variable? This is not a variable,
Test
right? This is
score
the serial number or the identity you can say.
test score will be dependent on IQ and study hours.
Which one?
Let's go.
Test
Test
score
score
will be
will
the
be
dependent variable.
Dependent. IQ and
okay.
study are independent.
Okay, right. You're right. So after identifying this, I have run the regression. Okay. So this is what my output is. This is how the output look like. You have multiple R, you have R square, you have adversary R square, you have standard error, and the number of observation will be here. So number of observation means how many number of samples are here, right? The degree of freedom, then degree of freedom per regression, degree of freedom per residual, total degree of freedom. Then what is this? SS, SSR, right? SSR, SSC, SST, MSR, MSC. Then F statistics is what is the formula? F statistics.
MSR upon MSE.
Yeah, perfect. And this significant value or this is the probability value, right? We'll be getting it from F table. You have to use F table.
Yeah.
Yeah, you had already used in BA1, right? F table. And the next, this is the coefficient table. Here you can see the intercept, mean the coefficient of the constant part. Whatever you have seen in the PPT, it was written as constant, right? Okay. Yeah, this is written as constant. So this is actually the intercept. If we talk more technically, this is the intercept value. The coefficient means the B value or the B naught here. B naught, then B1, then B2, right? So I know the coefficient value. If they ask me to write the regression equation, I can easily write. Okay, the regression equation will be, which one is my dependent variable here? Test score, right? So I can write test score is equal to 23.156 plus 0.509 into IQ
509.
plus 0.467 into study hour. Okay, everyone clear?
Yeah,
Yes.
Yeah. You all know how to run regression using Excel. You all know that.
yes.
I think we have to add it using it. I mean, using that file option, no, as an extension.
Yeah, you have to add the extension. It's not there in the regression part or the analysis part. toolpack is not there as a default in Excel. So you need to go to data. You can check here is this data analysis toolpack is there in your Excel or not. You can add it. I'm using Excel 7, so I can add it. I'll go here and there is the one option. Excel option is there, and I have add-ins over here. Will directly go, and whatever the things I record, solver I record, and analysis toolpack. These two are actually essential to run any kind of analysis in Excel using Excel. So this analysis toolpack will help in getting the regression function. Okay, so I have already added, and I will press OK. So it will be adding over here. So as we have enough time, so let me show how to run regression. Okay, should I or want to? Do you want me to show regression? How can we do that in Excel? Hello.
Yes.
कितना टाइम लगा देते हो तुम लोग यार. चलो data analysis, you have to click on that data tab, then data analysis. After adding only you will get this feature, data analysis. So here is one option, regression. I'll click OK. So they are asking me to input y range and input x range. Input y means what? My dependent variable range. And input x range means my independent variable range I have to add. Okay. So which one is my dependent variable here? Risk, age, pressure, and smoker. Which one is my dependent variable here? Can you all see the
Test
data?
score. Here.
Hmm? Don't you think it is the dependent variable? Risk.
Yep.
Risk is dependent on age, the pressure or blood pressure. This pressure means or blood pressure you have, and are you a smoker or not? Am I correct?
Yep.
Risk is the dependent variable I'm talking about. Correct now?
Right. Right.
Yeah. So to run the regression, I will be taking these three as my independent variable, and this is my dependent variable. But I can't run the regression right now. What will be the what is the mistake right now here, or what is the barrier you can say? Can you all tell me? If you have run the
Yes.
regression, yeah, yeah, go ahead.
Yes. No data in smoker.
Yeah, this is kind of what subjective type of data, no?
Yeah.
Not a numeric data. So Excel will not understand it.
Categorical data.
Yeah, categorical data is fine. 0, 1 is also categorical. Yes, no is also categorical. So this is subjective type of data, not a numeric data. Excel will not understand this subjective or non-numeric data, you can say, technical term. Non-numeric data Excel will not understand. So we have to change it to numeric data. So as it is small data, what I will do? I can use if function, right? Should I use that if function? I will not use it. So I've taken no for 0 for no and 1 for yes. Now I can run regression. So what I'll do, I'll go to data, then data analysis, then regression. Okay. So asking me input y range. So risk is my input y range, and next is my input x range. So these three are my x range. So I'll be taking these three, B, C, and D column. Okay. My data contains label. This is the label, right? Risk, age, pressure, smoker. I've taken from here only. I've not taken from column, sorry, row 2. I've taken from row 1. My row 1 contains label. So I'll be checking this box. And my data content label. And I want my output range to be present over here or somewhere here. Okay. Then I'll simply press OK. So this is what my regression output. Correct? Got it, everyone?
Yes.
It's very simple. So if you are going for your internship and you want to show some data analysis, generally people what people do, they use regression analysis in the data whatever they have collected in their during the internship. They generally perform regression analysis. So you must have to know how to run regression using Excel. Or if you have used SPSS in your SLP classes, you might know. Are you all using SPSS in your SLP classes?
No.
Yes.
No.
Who said yes?
I said
Who said yes?
yes. I Garima.
Okay, very nice. Yeah. So we can perform regression in SPSS also. I'll be showing how the output actually changes. Means value will be same, but output looks quite different. This is the regression output of Excel, right? I'll show you how SPSS output looks like. Is there any doubt in this part? It's very simple to run regression in Excel. Any doubt in this part, or I can proceed?
Just Subodhi, just one thing. This ANOVA is there, right?
Yeah.
So I think you have already talked, but F significance is fine. But for F also, in class, man was telling that some values should be there. It should be above certain value. So
A
uh,
value.
do we need to care about this or significance? नहीं, उसके side में F is there, right?
Okay, F.
Yeah. So do we
Huh.
need to care about it, or we can just
No, no.
see the
If you know
significance
the
F
F
and
value,
then
then only you can get the significant F value, right?
okay. No, but I'm saying here only significance F looking at that is fine.
I am not getting your question.
I'm saying it.
Hmm.
Is it necessary to look at the F value? Because
Hmm.
here we are doing in the Excel, right? So,
Hmm.
or only looking at significance F value is enough.
You have to look at all those values. They will not ask you to do this regression part. They will simply give you this ANOVA table. I'll be talking about that. Wait for some time.
Fine.
Why you need that? They will simply give you this table, this output ANOVA table. And here and there will be some missing value, and you have to find that value. Okay. So this is what the output is. Okay. This was the output. This was the different thing I was talking about. And next is, yeah. Look at the thing. This is what the SPSS output is. The regression SPSS output. This is this one and this one is the same output output of same data set. Okay, but it looks differently, and we'll be getting more statistical analysis using SPSS. We can do that, right? The value will not be changed. Value will be same, but the representation will be different. So this is what another example. My predictor or the what predictor means what? The independent variable, right? Here in my data set, the independent variable is outdoor ad expense, social media expense, and print media expense. And my dependent variable is profit. So profit depends on how much how much is my expense on outdoor ad, social media, and print media. Are you all understanding the model, regression model, the data?
Can you repeat?
Here I am not giving you the data set. I am directly representing the output, regression output. So my regression output, the model summary table, it's clearly written here. My dependent variable is profit, and my predictor means the independent variable here is outdoor ad expense is one independent variable. The second one is social media expense, and the third one is print media expense. So these all are kind of advertisement expenses, right? How much I will spend on advertisement, my profit will be varying accordingly. Correct? That is what the basics of this entire model. Clear to everyone?
Yes.
Yes.
Yeah. So I know my R square, adjusted R square, all those things I got. I'll come to this one. Darwin Watson, but I'll come to that. Next is my ANOVA table. This is what my look at this. In Excel, which one will come first? The DF part will come first, right? The DF, then SS, then MS, then F, and then significance. But in SPSS, SS will come first, then DF, then MS. This is how the representation will vary. Next is coefficient table. In coefficient table, you can find so many things. It's not there in, if we perform regression through Excel, you will not be getting these all these values. Okay, so here, yeah, I'll be talking. So what I was talking about, we know how to calculate R square at the R square, right? You all know how to calculate R square.
Yes.
Okay, then do it. Here are some missing values. I want these values from everyone. I want everyone to calculate this. Do you want to do, or this is the type of problem you
Can
can
we do it
expect?
together for the first sum?
Sorry,
Can we do it together for the first sum?
can you repeat?
Can we do it with while you are doing it? Matlab,
I have already done it in the last session. The simple linear regression who are there or who has watched the video, they can calculate. Anshu, can you calculate? You have watched the video, right?
but the recording for that session was not shared, no?
You said. Anshu, can you calculate? I remember who are there. Let me check. Yeah, who are there in the last session? No one is here today. Okay, I'll do that for. I have two problems, so I'll do the first one. So if we know the this is one type of problem you can expect. So if we know the R value, the R square value is missing in the table, I can easily calculate. So what I will do, I'll simply square this term. Multiple R, I'll simply square this. Got it, everyone? How to calculate R square?
Yeah, surely.
So it will be equal to,
But then R square is calculated later, no?
hmm, which one?
I'm telling that R square can be like has to be calculated later, no? At the end of the solution, like when we have SSE and SST, then using that formula,
No,
R
no, no,
square can.
not required. I know now how I can calculate. If I square this term, multiple R,
Okay.
I can easily get R square.
So in this way also we can calculate.
Yeah.
Is it what you are
But for
saying?
adjusted R square, you need to wait. You have to calculate all those things. What is the formula for
Yes.
adjusted R square?
1 minus MSC upon MST.
Yeah. So MSE and MST, MSE is not here. You have to find MSE also, and MST is not also not here. So MST also you have to find. Correct.
Yes. And how will we get here N
N.
50
N means
observations? 50
written,
observations,
na?
right?
Yeah. N is 50 here. Small n is equal to 50. It's mentioned here. So what will be K here? What do you mean by K?
3.
What do you mean by K? Don't you?
Number of independent variables.
Yeah. So how many number of independent variables are here?
3.
Yes. So K equal to 3. So this is what? ANOVA table, the first one, regression degree of freedom for regression is equal to k, right? K is 3 means this will be 3. What is the degree of freedom for residual? N minus k minus 1, right?
Yes.
Yes.
So n is 50.
46.
46.
Yes, 46.
46.
Another, yeah. Is there any other way that I can calculate residual degree of freedom using this one only? I know the total degree of freedom. I know one part.
Total minus
49.
regression.
49 minus 3. मतलब total minus regression.
Yeah, 49 minus 3 will also give me this value 40. Now this is SSR, right? How
Yes.
do you calculate SSR?
Total
Sum of
minus residual we can do.
Yeah, yeah, perfect. So I can do that. This one minus this one, correct? Is there any other way in this particular table for this particular scenario? Is there any other way that I can calculate?
Yeah, you can multiply regression DF3 into the MS.
Yeah, perfect, perfect, got it. So this one into this one, I'll get the same value, SS value. Okay.
you mean MSR into K?
This MSR into degree of freedom. Yeah, yeah, K. This is how I calculate. I know degree of freedom 3. SS is my this value. Okay. So how do we calculate MS? If MS is missing and SS and SSR and DF is 3 is given to you, how do you calculate this? SSR divided by 3, na? MSR is equal to SSR divided by regression degree of freedom. Now this value is missing, so how do we calculate this? MSR into this degree of freedom, correct? Are all clear?
Can you repeat?
Uh, M MSR formula is SSR divided by degree of freedom of regression. This is what the formula is for MSR. Now I know the MSR value. I know the degree of freedom of regression. Can I calculate SSR?
Yes.
Got it, everyone? Next is this one, MSE. MSE formula is what?
SSE by n minus k minus
SSO.
1.
SSE by degree of
N
N
freedom,
minus
minus K minus 1.
degree of freedom for error, right? So this
Yeah.
equal to this one, this 39 divided by 46. This one is the MSE. Next is MST. How do we calculate MST?
Say go for SST by total.
Yeah,
MSC plus MSR.
SST divided by
Total 49.
DF total. So MST value will be equal to this one divided by 49. This is my MST value.
Bhaiya, apart from this formula, any other formula to calculate MST?
No,
Only that.
only this one.
Okay.
Don't add this one. SST, how do we get? Adding by SSR and SSE.
Okay.
But don't add this one. You will not get the same value.
Fine.
Do you want to check? Let me check. The value is not same, right?
Mm-hmm.
Yeah. This is not the logic. Means SST we got using SSR plus SSE, but MST will not get by adding those particular two terms, MSR and MSC. You have to use this formula only, SST divided by degree of freedom, total degree of freedom. Okay. Now can you tell me the adjusted R-square formula? I can
Can you calculate MSE once again? Show the calculation of MSE.
MSC.
Yes.
MSC. Yeah, MSC formula is this one. No? I've written here. SSC divided by degree of freedom of error means 46. It's simple. If you know this one and this one, just this one divided by this one will give you this. Simple logic.
Okay.
Means a trick you can remember. If you want to calculate this one, you have to uh, that your numerator will be this one and denominator will be this one. If you want to calculate this one, your numerator will be this one and denominator will be this one. Like that you have to remember. Clear?
Yes.
Yeah, next is adjusted R-square. How do we calculate adjusted R-square? 1 minus
MSE
MSC
upon
by
MST.
MST. So MSC is this one and MST I have calculated here. So 0.947553. Let me check with the what I have taken. 94. Yeah, this is 948. I'm getting 94755. So I can say it's almost correct. Okay.
Can you say the formula again, please?
I like the formula.
Yeah.
This is the formula of adjusted R square. 1 minus MSC divided by MST. We all the things we have calculated in the last session, it's there in the Excel sheet. Clearly we have written. So keep it safely. The first Excel sheet what I have there. That will definitely help you in your semester exam. Correct. Next is F value. How do you calculate F value? The F statistics is also missing, right? What is the formula F value?
MSR by MSC.
This MSR divided by MSC. So this is my F statistics and this is my what it is the significant value. Okay. Everyone clear? Another thing in the coefficient table, the T statistics is missing. How do you calculate T statistics here?
Like
Coefficient upon standard of error.
we'll divide it.
The formula is T is equal to
B1 by S.
Upon SB.
B by SB or SB by B.
No, B by SB.
By SB.
Alright. It's B by SB. Okay. This is what the formula we know. And this is what my B value is. And this is what my SB is.
Okay.
Now can we calculate this? Equal to B divided by SB. Correct? Got it everyone?
Yes.
Yeah.
For the second one is this one divided by this one. For the third one, this one divided by this one. Like that you have to go. Clear everyone, I guess. Any doubt in that? Or I have another problem you have to calculate right now. Let's calculate this. Can you do that?
R is 0.9752.
Hmm?
R value is 0.9752.
9752.
0.9752.
Yeah, yeah, got it. 9752 you're getting. Okay. So yeah, yeah, I'll come to that one.
I did point 951 root.
Yeah. Yeah. So R value, how did you calculate here in this particular thing? How do you calculate R square? By squaring this multiple R, right? Multiple R or
Yes.
R you can say. Okay. R and multiple R both are same. Excel represent it with multiple R, but SPS represent it with R only. Okay. So both are same. So while calculating R square from R, we simply squaring this term multiple R. Okay. So now I know R square. I want to calculate R. So R will be under root of this one.
Root over
Yes.
0.95.
So I'll write equal to,
Raised to half. No?
yeah, 9750 is the value. Okay. Everyone got it, I guess.
Yeah.
Now you have to calculate what is this residual SSE, right? How to calculate that?
Divided sum of square by degree of freedom will get the mean square.
We can do the
But
difference also
this,
between.
wait. These two are also missing now. These three things are missing. How do you calculate that?
Um, okay, minus set na. Total
The
minus regression,
difference
you
is
get
And
Yeah,
the
minus
minus.
two.
CPL.
yeah. I know the total and I know one part, so I can get the other part also.
Yeah, same thing
If
goes for
I,
DF also. Total minus regression, you get the
yeah,
residual. We'll find it.
for 46 will be the value. Now I can easily calculate. The mean square is equal to SSR divided by this degree of freedom. Next one is this one divided by this degree of freedom. My statistics will be equal to this one divided by MSR divided by MSC. Okay. Got it?
Yes.
Yeah. Now see this one. This is B. The standard error means SB. Okay. And this is the T statistics. The representation is quite different. I have taken the SPS output here, and previously it was the Excel output. Forget about this one. So I want this and this to calculate this one. My formula was what? This one was my formula,
B by SB.
B by SB. So I have to calculate B here. I know T and SB. So B will be what? B equal to T into SB, na?
Yes.
Uh,
So T is this one, SB means this one. Yeah, that's correct. I hope it's clear to everyone. Is it clear to everyone?
Yeah.
Yeah.
Now we'll be introducing another concept, another new term, this VIF and tolerance. We'll be talking about this. So before we talk about this, anyone has any doubt in this part? You can quickly
Can you
clarify.
tell the B
Yeah,
column again?
this one.
Yes.
Yeah. So in this part, my key statistics was missing. I know B and SB. B means the coefficient part and SB means
Okay,
standard
okay.
error.
Yes, got it.
Yeah.
So the T column you have taken
Yeah, yeah.
7.626.
This one.
That.
Yeah, yeah.
Okay.
This is T and this is SB. I know T and SB in my formula. So B means T into SB.
What is standardized and unstandardized coefficient?
Parity. Okay, this one.
Yes, yes.
You want to know that?
If it's not important, then we can leave.
We will talk later. This is very deep. You don't know right now what is VIF and tolerance. You want to know this one. We'll talking about this later. If possible, we'll take one session on regression on SPSS, and I can help you on that part, the detailed analysis of regression. If possible. I'm not. It's not a commitment. So that time we can discuss all those things. There are so many statistical terms in the regression part. We are only talking about the main things. Now you have to know all those things. I hope it is not also there in your syllabus. The interpretation part means what is the meaning of this value? R value is this, R square value is this. What is the meaning of that particular value? I am getting my question. Why I am calculating this one? What is the use of this R and R square as a shared square? All those things. Darwin-Watson. What is the meaning of this Darwin-Watson? Any doubt any till now? Or else we can start with VIF and tolerance. Anyone? No doubt.
No.
Okay, chalo then. So there is one term which is called as VIF and tolerance. So this is what the collinearity statistic is. You have to calculate this in your exam also. For multiple linear regression, it will be these values will be missing. Either tolerance value will be missing or the VIF value will be missing. So you have to calculate that. Okay. So if you want to write the formula, you can write tolerance is equal to tolerance is equal to 1 by VIF.
What? Tolerance equals to?
मैं तो डर गया था सच में.
मुझे कुछ और
Tolerance
सुनाई दिया.
tolerance is equal to 1 by VIF. Okay. Now coming back to this one. Can you calculate this?
Yeah.
1 by tolerance.
Yeah.
VIF.
1 by tolerance.
But like
In the
tolerance,
question paper, even in the question paper, they'll give us either tolerance or VIF, right?
Yeah.
same thing I was asking.
This is the format. This coefficient table will be getting like this.
No, no, like we were asking like either tolerance will be given or VIF will be given.
Anything. If VIF is given, you can calculate tolerance. If tolerance is given, you can calculate VIF.
Like that, na, ki both is like empty, then you have to fill it by
How
half.
to calculate them? No, no, no. It's not possible. This is what the format is. This is what the format is. I've taken from the questions and from my experience. Can you calculate that? First one will be 0, right?
Yes.
What is the second one? Equal to 1 divided by this value, 2.469.
2.469.
1469.
Yeah.
Then it will be 1.75.
2.3256.
Yeah.
Bro, in the first case, 1 divided by 0, how it would be 0?
Undefined, na?
It will be 0. In the exam paper, it will be
0.
missing here. There will be no value.
Yeah, okay, fine.
Don't go sometimes you need not to go mathematically. You have to think sometime logically. That was a nice doubt actually. Who asked the doubt? No, Sarma थे मैं तुम लोग. So it's clear everyone. Either tolerance value will be missing or the VI value will be missing. So any one value in either of the value will be given to you. Okay. And the next or the last thing is the Darwin-Watson. So before coming to Darwin-Watson part, uh, formula. Okay, Darwin-Watson you don't need to calculate actually. You just need to have to know the significance of that. What is Darwin-Watson? So I'll come to the significance but one by one. First I'll talk about R square, then Alistair R square, then Darwin-Watson. Okay. Then the VI. What is the meaning of VI here? These all are important. And what is the significance of this B? What is the significance of this B value? Can anyone tell me? What is the significance or use of this B value?
Beta.
Not beta, BV. Simple answer. Yeah. Using this B value, I can easily write a regression equation. That is the answer. Okay. So from the coefficient table, if you know all the B values, you can directly write the regression equation. Now come back to that. So first is multiple R. What is the meaning of that multiple R or the interpretation of that multiple R or the R value? So R value shows the correlation or the strength of relationship between the independent variable and the dependent variable. R value shows the correlation or strength of relationship between the independent and the dependent variable. R value lies between -1 to 1. The value nearly equal to 0 determines weak relationship between the variables. So can you all understand what it talks about? It is only talking about the correlation part. Are you all getting? Did you all remember how many types of correlation we are talking about? Positive correlation, negative correlation, and zero correlation. Did you all remember that? Positive, negative, and zero correlation. Hello? Someone can reply, yeah? Am I audible?
Yes, yes, we remember.
Yeah.
Audible.
So,
Audible.
if I mean, uh, if both are in the increasing side, we call it as positive, and if the both the data sets are in the opposite sides, I mean, one is increasing, other is decreasing, then we say that they have a negative relationship.
Like
Yeah.
price and demand is negative and price and supply is positive.
So that is what whatever you have understood from correlation, that is what it is talking about, right? R value shows the correlation or the strength of
Yeah.
relationship between the independent and the dependent variable. So whatever we have taken the independent and the dependent variable, it's the value shows the correlation between those two variables or those two types of variables you can say. Independent variable, how many independent variables are there? They will be considering as one, all the independent variable and one dependent variable. Okay. So R value lies between -1 to 1. Correlation value also lies between -1 to 1. The value -1 means highly negatively correlated value, very correlated means correlation, or the positive +1 means what? Highly positive correlation, I can say. The
Yes.
value nearly equal to 0 determines weak relationship between the variables. So the value nearly equal to 0 means what? There is no relation between the independent and the dependent variable. Okay. So here the value is how much? 0.975, which is almost nearly equal to 1. So what I can interpret? I can
Strong
interpret that,
Strong positive relationship. I
yeah,
mean, would be
yeah, yeah,
either aggressive or defensive.
correct. So this in this particular model, I can say dependent variable and then my predictors or the independent variable uh, has strong positive correlation. That is what my interpretation from this particular value. Now can you interpret it? If they ask you, if they give you this value, R value is 0.975. So what is your conclusion if they ask? Can you interpret that? Can you interpret that? Look at this one. Correlation predicting that. So this is what positive correlation, this is what negative, and this is what zero correlation. So sales and price, what type of correlation is it is? Sales is dependent and price is independent. What type of correlation it is?
Positive correlation.
Positive. Price, I'm
Negative,
not
negative.
talking about cost.
It should be inverse, no? Because like if the price goes up, the sales would go down naturally.
Yeah. I'm talking about price. My variable is cost is not my variable. Yeah. If I say cost, then it will have positive correlation. Cost will be in term like cost will be incurred by the company. Price will be uh, incurred by the customer,
Customer.
right? Yeah.
Yeah.
So if price is high, then customer will not buy that product. So sales will be decreasing. That is what negative correlation.
Negative correlation.
Yeah.
Yes.
Exercise and fitness.
This would be
Exercise is
because
This
yes.
will be
exercise is dependent variable or independent variable here.
No, fitness is dependent on exercise.
Correct. Fitness is a dependent variable and exercise is my independent variable. So
Yeah.
if we exercise more or we work out more, then we'll be more fit, right? So if both increase, then means one will increase, another one will also be increasing.
Also increase and vice versa.
Yeah. So this is what the example of positive correlation.
Positive correlation.
Yes. As a negative correlation, sorry, zero correlation is I've taken the example of price of coffee and sale of mobiles. There is no relation. What is the relation of price of coffee increase or decrease? What is the relation of sale of mobile? No relation. No?
Yeah, correct. No relation at all.
So this is what the example of no correlation. And this is what actually the representation of R in terms of the regression model, the R value,
I
the
think this,
relation between dependent and the independent variable. Independent variable, how many independent variable are there? They will be taken into consider taken as one variable in that particular model. All the variables will be taken into consideration, but that will be taken in one variable. Okay. Next, I hope it's clear. R value is clear, right? Any doubt? R multiple R value or the R value interpretation? बता दो यार. Yes or no?
yeah. It's,
I think there was a lag from my side. तो last sentence मैं सुन नहीं पाया.
I was asking that is there any doubt on that?
Okay, okay, fine. No, got
I
it.
hope it's clear again, right? I can proceed to next one. Next one is
Yeah.
R square. Okay. So how do we get that R square value? If we calculate it, we are just squaring this particular term. So I was talking about R value lies between -1 to +1. So what will be the limit of R square value? Can anyone tell me?
from 0 to 1.
Yeah. Everyone got it? Why she said 0 to 1?
Yeah,
Once
because
you can,
If
huh?
you square, it will come in positive.
Yes. So we are just squaring this particular term. So if suppose the value here, uh, let's think the value here is -0.975. So it's strongly negative correlation, I can say, R value. According to the R value, if the value is -0.975, I can say uh, strong negative correlation is there with dependent and independent variable. But if you square this particular term, that will be positive here. So R square value always lies between 0 to 1. That is what I write here. R square value lies between 0 to 1. The first line says that R square value shows the goodness of fit. Goodness of fit means what? How much my model is significant or not. Whatever the dependent or independent variable I have taken into consideration for regression, is that perfect or not? Okay. Think about this one. Price of coffee and sale of mobile. इसका unmute है. Rohit, can you mute? Or do you have any doubt?
No, I'll mute myself.
Yeah, yeah. So suppose in the regression I have taken price of coffee and sale of mobile. Either of either of these two variables I've taken one as dependent and another one is independent variable. So what? There is no relation. No? What is the use of running regression here? No use. Correct?
Yes.
Yeah. So
Yes.
this is what the meaning of goodness of it. Whatever dependent and independent variable I'm taking. So is it good or not for the model? Got it, everyone? What I am trying to say.
No,
Yes.
it didn't.
Means basically if
Can
it
you
is well suited to the model or not. That's what you're saying. No?
Yeah. So whatever, yeah, I'll repeat that. Whatever dependent or independent variable I'm taking, is that good for running the regression or not?
Yeah,
Suppose,
yeah.
suppose I am taking price of coffee and sale of mobile, these two variables, and I'm running simple linear regression. Suppose, okay. So I can easily say with the visual inspection or by understanding these two variables easily, I can say that there is no relation. So if there is no relation among these two variables, will that be significant to run regression analysis? Also,
No,
can
no,
you tell? Yeah,
no.
yeah. So this particular R square value actually shows that whatever the variables I'm taken into consideration for regression equation or regression model, that is perfectly fit for regression or not. Got it?
Yes, yes, because they both are interrelated. So we have
Yeah.
to find like if the values are interrelated, then only we'll try
Yes.
this model.
There is relation. That is why we're running the regression. Na? If there is no relation, we will not be running the regression equation, regression analysis. Means if R square value is nearly equal to 0, we'll directly eliminate the analysis. We'll not be looking into other values. Okay. So there is one limit for R value. This R value, particularly this R value, there is one limit. Generally, the researcher take the R value as greater than 0.04. That's sorry, zero point 0.4. Okay. Generally, they do. Okay. When the R value is 0.04, some research you will also find R value is 0.0, zero 0.5 actually. Sorry, 0.04. It's zero point 0.4. Okay. Zero point 0.4 or zero point 0.5. R value should be greater than 0.4 or greater than 0.5. Then only we can say this model is good for regression analysis, or these variables what we have taken into consideration is good. Got it?
Yes, yes.
Yeah.
yes,
So here I can say that R value is 0.975, so I can proceed to further analysis. So my R square is 0.951. Okay. So this is how we write the interpretation. Here the R square value is 0.951, 951, right? 0.951, which signifies that the dependent variable, which one is my dependent variable here? Profit, right? My dependent variable profit is, how much was the value? 951, right? 0.951. So 95.1% in association with the independent variable. 95.1% association. Are you getting it? 95.1% means it's highly in relation. Okay.
Yes.
The dependent variable and independent variable, what we have taken, the independent variable actually defines the dependent variable, and the The definition part is how much? 95.1%. That is truly amazing for analysis. Okay. Yeah. Next, another interpretation is R square value will only increase if we add extra explanatory variable. Explanatory variable means the another name of independent variable. So if we, how many independent variable are here? 3, right? This R square value will increase. R square value will increase if we add, suppose one more variable we are adding. The R square value will increase. Got it?
Yes, means on an increase of the variable, value will increase only.
Yeah.
Okay.
Next is adjusted R square. So adjusted R square, what is written here? It helps in analyzing the extra independent variable which are added have really any significance or not in the regression model. What I was talking about. If we add extra independent variable, R square value will increase. But this adjusted R square actually helps in analyzing whatever the extra independent variable I am adding, that is really having any impact or not. Suppose I am talking about sales and price. Okay, sales is my dependent and price is my independent variable. I am adding another variable which is the quality of product. Okay. After adding quality of product, my R square value will increase. Okay, got it?
Yes.
Yeah. Next is after adding this extra independent variable which is quality of product, if the adjusted R square value decrease instead of increasing or being into fixed point, if the adjusted R square value decrease, what I can say this variable is not actually good for the analysis. Means sales and quality of product is not having that much impact among each other. Are you getting my point?
No, no, the value decreases. Okay, so the quality of the regression decrease. So we say that, I mean, that makes us conclude what you said right now, right?
Hmm.
Okay,
Yeah,
okay.
yeah, you got it.
Yeah, yeah, okay.
Yeah. Anyone any doubt or any confusion in that part?
Got it. Got it.
So what it is written over here is this adjusted R square helps in analyzing the extra independent variable which are added have really any significant or not in the regression model. If by adding extra independent variable the adjusted R square value decrease, then we can eliminate those variables. Means I'm adding the quality of product over here, right? Quality of product for sales. After adding that quality of product, if the adjusted R square value decrease, I can eliminate that variable. Okay.
Yeah.
Now it's clear this 3 times. R square, adjusted R square, and sorry, R adjusted R square and adjusted R square. Next is Darby-Watson. You have to know the interpretation of that.
How to
Darby-Watson.
calculate that Durbin Watson? Can you tell?
There is one formula, but that is you don't have to calculate that manually. You want to know the formula? I'll tell you that. Wait.
Will it come in exam?
No,
Then it's okay.
it is summation of the error EI, summation of EI minus EI minus 1 whole square divided by summation of EI square. You don't
ये
need to
किसका
calculate.
फॉर्मूला है?
Huh?
ये किसका फॉर्मूला है?
Darby-Watson if you want to calculate it manually. But for that you have to calculate E and all, the error term and all those things you have to calculate. You don't have to calculate that, you just need to interpret this one. What is Darby-Watson value will be given to you, this value suppose. What is the meaning of this particular value? You have to interpret that. So what it says, Darby-Watson statistics helps in finding the autocorrelation of the residual. What do you mean by autocorrelation? If you have watched the video of last session, you can explain that. What do you mean by autocorrelation?
The relationship between the variables of the current value and the past.
ए, कुछ भी guess मत करो रे.
Basically, like you give
Sorry.
an example that when a faculty teaches, one student will get like very high, one student will get low.
Mm-hmm. Oh, right, right,
So
right.
it is different like across variables.
Yeah. Uh, if you are not there in the last session, if you want to write the definition of autocorrelation, because that is very important term. One is autocorrelation, another one is multicollinearity. Can you see that this one, multicollinearity? I'll come to that term. These two terms are very important in regression analysis. So if you want to write the definition of autocorrelation,
Please tell.
yeah. The autocorrelation refers to the degree of correlation
Hmm.
Autocorrelation refers to the degree of correlation between the values of the same variables
Yes.
across different observations in the data. Across different observations in the data. So what she was talking about the example what I've given. So suppose I am helping you with BA, okay, but are you all getting the same marks? You 10 people are here. Are you all getting the same marks in the exam?
Uh, I wanted to ask
No.
you.
I am delivering the same thing to everyone, right? I'm not delivering any different things to, uh, like, personally, I'm not delivering anything to anyone. I'm delivering the same thing to everyone, but you are not getting the same marks. So there is a difference, like,
But how is it different from correlation?
sorry,
Like one or the other way, it is the same thing, right?
the correlation between my explanation and your getting of marks, how much marks you are getting.
Okay.
It's different, na?
No,
If
no. No, like, yeah, but I'm asking how is it different from the classical correlation that we have known?
it's saying the same data actually, the same data you have to take.
Okay, okay, and that is between two different data sets.
Yeah.
Yeah, okay, okay.
Can you give another example to explain,
This is
please?
the best example. For not understanding with this one, how can I? This is the best example, and you can relate actually.
Again, can you explain it?
Yeah. So I am delivering the same thing to each one of you. Like I'm
Right.
not helping anyone personally, or I'm not telling anyone personally anything. Still,
Okay.
there is a variation in your marks you are getting in your exam.
Yeah.
Okay. So you 10 people are here. The observation, 10 observations I can say.
Yes.
What I said, say in the definition, the value of the same variable. Here, the variable value of the same variable means what? The marks is a variable here,
Mm-hmm.
and the and another one variable is what? My uh,
Teaching.
I'm not teaching. My helping capability. My helping capability.
Yes.
Okay. Now you have got it, I guess.
Mm-hmm. Okay.
So this is what Darwin-Watson statistics helps in finding the autocorrelation of the residual. The value now you have to interpret with respect to the value. The value of Darwin-Watson scale in between 0 to 4. The value will always be in between 0 to 4. Okay. The value above 2 indicates negative autocorrelation. Means negative means what? One will increase, another will decrease. Correct? And the value below 2 indicates positive correlation. Remember this one. We sometimes got confused. Value above 2 means negative. Value below 2 means positive. Got it?
Yeah.
You have to remember this, and you have to know what is autocorrelation. Here, the important thing is that what is autocorrelation and this particular value, the limit of this and the particular value, what does actually difference. Okay. Next I was talking about the VIF and tolerance, right? So what is VIF and tolerance? So from the collinearity statistics, that was the collinearity statistics, right? This one, the part of tolerance and VIF was the part of collinearity statistics. So from collinearity statistics, the tolerance is closer to zero indicates high multicollinearity. How much was the tolerance here? What do you mean by multicollinearity? Has anyone heard this term before? Multicollinearity. Anyone of you heard this term before?
It's just a guess. So basically, collinear is when you have points along the same line, right? So is it that high multicollinearity means those points are more in number and are not and are less dispersed? I mean, they are less deviated from the main straight line, something like that, and more in number as well.
Multicollinearity means
Can I say?
Mhm.
So it's like when two or more variable of a model are dependent upon other variables,
Hmm. Then
such that we can linearly predict which one is the high degree of accuracy and all. Something
वो
related.
कहाँ से मिला ये?
सर विशाल सर ने कुछ थोड़ा बहुत बोले थे इसके।
ए, फटाफट
विशाल सर बोले
चलो
थे, मुझे याद नहीं आ
चलो मैं बताता हूँ। अरे
रहा।
मैं बताता हूँ। Multicollinearity is, if you want to know it in a simpler way, multicollinearity means the relationship between the variables. Okay, so relationship between the independent variables actually. So I have taken outdoor ad expense, the social media expense, the print media expense, right? How much these three variables are interrelated among each other. Got it?
Can you
If
repeat?
the multicollinearity defines how much the independent variable which I am taking into consideration for my regression equation, how much they are correlated. Okay, so in this part they are saying the tolerance is closer to zero indicates high multicollinearity. The tolerance value for this particular variable, why this tolerance value is zero here, or there is no tolerance value? This is not a variable, right? It's a constant term. For this particular variable, print media expense, the tolerance value is nearly equal to zero, which defines that there is a high multicollinearity present. Means what? If
All
there is
the,
high, huh?
the independent values are related, like then.
Yeah. So what I can say, if it is having high multicollinearity, I can eliminate that variable. Suppose here I can say there is no multicollinearity present. Zero point 0.4 is quite good. Tolerance value 0 0.4, 0 0.8, and zero point 0.4 here also it's quite good. Suppose the tolerance value is almost nearly equal to 0.2, or suppose it is 0.1, so nearly equal to 0, I can say.
Yes.
Yeah. So when it will come at nearly equal to 0, suppose I am taking uh, let me come back to this point. Suppose I am taking sales as my variable. Okay, and okay, let me take on another example. Suppose fitness is my variable. I am taking exercise. Fitness is my dependent variable. Exercise is my independent variable, and I'm
Suppose
taking,
yoga, like yoga. If
yeah,
data
yoga, yeah. Exercise and yoga, both the variables are similar kind, right?
Yeah.
Can you get my point? Exercise and yoga, both the variable, I'm taking two variable into consideration, but both the variable are similar. There is not much difference. So instead of taking these two variables, yoga and exercise, I can consider only one variable now. Try to
Okay.
understand that. This is the last point actually.
So basically, means any of the two variables, right?
Yeah,
Mhm.
got it. When the two like the independent variables are interrelated, then the tolerance value will be zero. And instead of taking those many variables, I can take only one variable. Either I can take exercise or I can take yoga.
Yeah, yeah, got it.
Got it, everyone. This is important. Multicollinearity. I am taking so many variables, but the variables are correlated. So instead of taking those many variables, I can take only one.
yes, yes, got.
Everyone. This is the last part actually, so I can spend some time. Everyone got it. No load have. Everyone got it.
Yes.
Yeah. So VIF is a reciprocal of tolerance that we have already calculated. Small vi represent low correlation among the variables. Same thing, correct? Low correlation. Small vi, this will be opposite, right? Tolerance is low means vi will be high because that is 1 by something, right?
Yes.
Yeah. So the value of tolerance greater than zero point 0.1 and vi less than 10 indicates no multicollinearity. The value actually we are taking zero point 0.1, greater than zero point 0.1 tolerance value will be taking for our analysis. And VIF less than 10 indicates no multicollinearity present. In this case, okay, this is a, sorry, this yeah. So VIF greater than 5 indicates indication of multicollinearity. VIF greater than 10 means high chance of multicollinearity. Greater than 5 means it's already it's started with it's actually given the indication of multicollinearity. Okay. Greater than 10 means multicollinearity is there. So let's check what multicollinearity is there or not. It's not there, no? It's less than 5, correct? Means whatever the variable you have taken, the variables are not that much intercorrelated.
No, if it is greater than 5, then we will say multicollinearity is there, no?
Yeah. If it's greater than 5, then we can say instead of taking these three variables, we can take into consideration any two or any one. We can eliminate one variable.
Scroll
Yes, yes,
down.
yes.
Hmm?
When you scroll down, like there was one thing written: if VIF is greater than 10, which indicates no multicollinearity.
No, it's
High.
Oh, it's less than 10. Okay, okay.
which one? Why?
The third sentence. Okay, okay, it's
Okay.
my fault. It's less than 10. Okay.
Yeah. So greater than 5 value means it has the indication of multicollinearity. Greater than 10 means high chance of multicollinearity.
Yes, I got it.
Yeah, it's done. Regression, multiple regression is done. Any doubt, anyone?
Actually, I wanted to talk about